This is me Arzu here and I welcome you to my channel Mr. Teeth, where your dental concept get dissected. So this is our part 4 video of the dental cement series, and in this video we will be discussing with the zinc oxide eugenol cement. Okay, so as in previous video I have discussed with the silicate cement and the zinc phosphate cement. Today we will discuss with the zinc oxide eugenol cement and we will cover all those important topics of this chapter. Okay, so without delaying much, let's start today's video. So as I have written here, the ADA number of the zinc oxide eugenol cement is 30. Okay, and it is extensively used in the dentistry since 1890. Okay, after that I have written it is a low strength cement, least irritating, and provide obtundant sedative effect to the exposed dentin. Okay, so this is most important line of this chapter. Okay, so this is a low strength cement. Okay, similarly it is a least irritating cement. Okay, least irritating, it doesn't irritate the pulp much. Okay, as like the silicate cement. As we discussed in the silicate cement was highly acidic. Okay, so it had a extreme irritation on the pulp. Okay, it caused extreme irritation on a pulp, but in this zinc oxide eugenol cement it is least irritating. Okay, so this we should remember. Also low strength cement we should remember, and it provides the obtundant or sedative effect. Okay, it provides the soothing effect. Okay, so this is most important point in this chapter. Okay, after that I have classified the zinc oxide eugenol cement, okay, in the 4 category. Okay, and it was on the basis of, okay, so ISO 3107 is to 2004. Okay, classified the zinc oxide eugenol cement into the 4 category, and type 1 zinc oxide eugenol cement is a temporary cementation. Okay, similarly class 1 is for, okay, under this type 1 zinc oxide eugenol cement, okay, there is a class 1 and class 2. Class 1 is a sitting cement and class 2 is a non-sitting cement. Similarly, type 2 zinc oxide eugenol is for primary permanent cementation. Type 3 zinc oxide eugenol is for basis and temporary restorations, and type 4 for the cavity liners. Okay, so just remember this: type 1, type 2, type 3, and type 4. Type 1 for temporary cementation, type 2 for permanent cementation, type 3 for basis and the temporary restorations. Okay, and type 4 is for the cavity liners. Now it is available in the 2 form. One is powder and liquid system, and another 2 paste system, as we discussed earlierly in our silicate chapter and in zinc phosphate cement. Okay, so we used to get the powder and liquid system there too, and also there was a capsule. Okay, but here there is not capsule. It is available in the 2 paste system. Okay, so it is quite similar with that of the, okay, I have missed to tell you that this zinc oxide eugenol cement is similar with the zinc oxide eugenol impression paste in many aspects. Okay, so just relate both those things. Okay, so in zinc oxide eugenol paste, also in impression paste, we will discuss with that in detail in impression chapter. Okay, but for now, in that too, okay, zinc oxide eugenol paste too, there was a 2 paste system. Okay, now commercial names for the zinc oxide eugenol cement is temp bond, DPI zinc oxide, and calzinol. Okay, now the composition of the zinc oxide eugenol. So in the composition, as we can see, we have powder and we have liquid. Okay, so in powder the ingredients are the zinc oxide. Okay, the weight is 69% and it is a principal ingredient present in the powder. Similarly, white rosin is there, zinc stearate, zinc acetate is there, and their weight percentage by weight is given there: 29.3, 1% by weight, 0.7% by weight. And the function that it carries are: white rosin, it reduces the brittleness of the said cement. So we should remember this: it reduces the brittleness of the said cement. Zinc stearate, it is an accelerator. Okay, it acts as an accelerator or a plasticizer. Similarly, zinc acetate, it acts as an accelerator too, and it improves the strength. Okay, after that, magnesium oxide, it added as in some powder and acts with the eugenol in a similar manner as the zinc oxide. Okay, so it is quite similar with the function of the zinc oxide. So 4 main constituents are these 4. Okay, zinc oxide, white rosin, zinc acetate, and zinc stearate. Okay, so I have also mnemonic for this. Okay, so Z we have in 3 and W. Okay, so when we complete this Z, okay, as I have discussed in zinc phosphate 2, okay, so there was magnesium, here there is W. Okay, so when we complete this Z, okay, it forms the M, and when we the mirror image of M will forms the W. Okay, so there are 3Z and 1 W, so you can remember in such a pattern. Okay, so zinc oxide, white rosin, okay, white rosin is just 1, and zinc stearate and the zinc acetate. Okay, and another one supplementary oxide is magnesium oxide present there, and the percentage by weight is 69%, 29%. Okay, so there is 9 in both the zinc oxide white rosin, and zinc acetate and acetate are in very little amount, 1% and 0.7%. Okay, and the functions are important. They are principal ingredient, and white rosins are to reduce the brittleness of the said cement. Similarly, the accelerator, they are the plasticizers, and accelerator, they are also improving the strength. Okay, so they both are the accelerator. This, yeah, act as a plasticizer, and this act as a improving strength. Okay, now in liquid there is a eugenol and the olive oil, so it is very easy. Okay, so if you learn the composition of this zinc oxide eugenol cement here, okay, it is similar with that of the zinc oxide eugenol impression paste. Okay, I am telling here only. Okay, so while we will study about the composition of the zinc oxide eugenol impression paste in impression chapter, okay, in prosthodontics, at that time you will see similar kind of composition. Okay, so just remember that the ingredient is eugenol and olive oil. Eugenol is 85% by weight, 15% by weight is olive oil, and it reacts with the zinc oxide, so it is a major constituent, and the plasticizer is the function of the olive oil. Okay, now in the setting reaction, okay, so setting reaction and the microstructure are same as that of the zinc oxide eugenol impression paste, as I have discussed earlier, and it is a two-step reaction. Okay, this is also similar with that impression paste. So covering this cement, okay, will also cover that chapter. Okay, so when you will see that chapter after studying the cement 2, you will relate lot more things. So two-step reaction is there, one first step and second step. In first step there is hydrolysis, zinc oxide is reacted with the H2O, it forms the zinc hydroxide, and in the second step the zinc hydroxide that is formed, okay, it acts as a base, and the that is eugenol. Okay, 2H, it acts as an acid, forms a salt, zinc eugenolate, and 2H2O. So zinc eugenolate forms the matrix. Okay, so zinc eugenolate matrix is formed there. Okay, upon which, okay, in which there is a zinc oxide particles present. Okay, so this is a structure of set mass. Okay, so in set mass we can see that the zinc oxide particle are present in the matrix of the zinc eugenolate. Now the chelate, okay, so zinc eugenolate, that is a chelate that is formed. Okay, it is in amorphous gel form earlierly, but that tends to crystallize, imparting the strength to the set mass. Okay, so remember this. First of all, it is in the form of amorphous gel, but later it crystallizes and impart the strength to the set mass. After that, in properties section, okay, so in the properties section, okay, so in the properties section, as I have mentioned here, first we will discuss with the mechanical properties. Okay, so the mechanical properties we will discuss compressive strength, tensile, and the modulus of elasticity. So I have written here, it is a weak cement. Okay, so as I discussed earlier, it is a low strength cement and least irritating cement. Okay, so it is a weak cement. Type 1 and type 2. Okay, so with type 1 there is a 6 to 28 MPa, and type 2 there is a 45 to 55 MPa megapascal. Okay, similarly the particle size affects strength, smaller are stronger, and also increases by the adding or reinforcing with the alumina. Okay, so as the, this is important. Okay, as the particle size is smaller, okay, it will strengthen the cement. Just remember this. Okay, smaller the particle size, it will strengthen the that particular cement. Similarly, it also increases by adding or reinforcing the alumina. Okay, so I will discuss with this in the modification of a zinc oxide eugenol cement okay topic. Okay, so there we will discuss about this alumina EBA. EBA means ethoxy benzoic acid. Okay, or polymer. Also we add these two in the zinc oxide eugenol for reinforcing them. Similarly, the tensile strength is 0.32 to 5.3 MPa, and modulus of elasticity is 0.22 to 5.4 GPa. Okay, so just remember those data. Okay, sometimes they can ask you in viva, but they mainly don't ask any sort of data in the viva. Okay, they just ask a conceptual question, but it doesn't depend, but it is not any rule there, they can't ask the data. Okay, so you just get prepared about those also. And theory exam, will you will write the properties of this zinc oxide eugenol, you must write those data. Okay, so just remember them. Now in thermal properties, okay, so in the thermal properties, as I have written, thermal conductivity is 3.98 calcium calorie per second per centimeter square. Okay, into 10 to the power minus 4. So thermal conductivity is this, so that is a good thermal insulator. Okay, and are approximately similar to the dentine. So this is a one of the most advantage. Okay, so this is a one of the advantage of this cement, that it is a good thermal insulator. Okay, that is approximately similar with the dentine. Coefficient of thermal expansion is 35 into 10 to the power 6. Okay, so remember those data. Okay, now in the solubility and disintegration section, as I have written here, it is highest among the cement. Okay, so there is highest solubility present in this cement, that is 0.4 to 1.5% by weight, and it is decreased by increasing the powder to liquid ratio. So it is a thing of common sense that if there is increase in a powder, okay, so there will be decrease in a solubility form. Okay, Now in film thickness, ISO maximum for the zinc oxide eugenol is this much. Okay, so ISO have told that the maximum film thickness of the zinc oxide eugenol should be this 25 micrometer. Okay, and its film thickness is generally higher than other cements. After that, in addition, okay, so it is also no chemically bonding. Okay, no chemical bond is present there. Okay, so it binds by similar as that of the zinc phosphate and the zinc silicate. Okay, there was also not a chemical bond, just they adhere by the micromechanical bonding. So there is also micromechanical bonding. After that, in physical properties, so the pH is 6.6 to the 8. Okay, it is least irritating of all cements. Mild pulpal response is present there. Okay, so as I have discussed earlierly, okay, so it is quite of alkaline. Okay, 6.6 to 8. Okay, so it is quite of alkaline. Similarly, it is a bacteriostatic and obtundent effect is obtundent property is present there, irritating to the skin and the eyes. Repeated contact. Okay, so the pH is 6.6 to 8. Okay, and it is least irritating to the pulp as compared to other cement, and their mild pulpal response is present there. Similarly, it is bacteriostatic. Okay, so just they control the growth of the bacteria, also provide the optimum effect, soothing effect. And repeated contact of this, okay, repeated contact of this may cause the allergic dermatitis. So just remember this. Okay, allergic dermatitis is caused if there is a repeated contact of that zinc oxide eugenol cement on the skin or the eyes. Okay, similarly in the optical properties we will say that it is opaque. Okay, similarly in the material interaction, so this is important among all those points. In material interaction, eugenol interferes with the hardening and or cause a softening of the resin based restoration, and therefore contraindicated as a base under the restoration. So just remember one thing, that when we are using composite resin, okay, composite based material, resin based material as a restoration purpose, okay, so at that time we can't use the zinc oxide eugenol as a base, because the base, okay, so eugenol that is present in this zinc oxide eugenol would interfere with the hardening and the softening of the resin based restoration. So just remember this point. Okay, so they can ask, of course they will ask this question in a viva. So now in the manipulation section, okay, so as I have written here, okay, so in the manipulation, the powder to liquid ratio, it should be 4:1 to 6:1. Okay, so this is a range. Similarly, the major amount of the powder and the liquid are dispensed on the cool glass slab. Okay, and bulk of powder incorporated into the liquid and are spatulated in a circular motion. Okay, so one thing I want to add here, that okay, as I have written, the major amount of the powder and liquid are dispersed on the cool glass slab. Okay, so it was compulsion in the zinc phosphate. Okay, because the reaction was exothermic there, so you can't miss, you can't afford missing that cool glass slab in the zinc phosphate. Okay, but here it is not so compulsion, but usually the glass slab is cool. Okay, so we use cool glass slab. Okay, and every reaction have little production of heat too. Okay, so it is a cool glass slab we use, and bulk of the powder is incorporated into the liquid. Okay, so this is important here. Okay, so we add in the, as in the zinc phosphate, okay, we just add small increment first of all, and after that larger increments are added. But in this, okay, there should be bulk addition of the powder into the liquid. Okay, bulk addition should be there, and spatulation should be in a circular motion. Okay, so just remember this. And another important thing is a pseudo thickening. Okay, so in pseudo thickening, as I have written here, it appears thick during the early spatulation, and further vigorous spatulation loosens the mixture. Okay, so when we are just first of all adding the bulk of the powder into the liquid, okay, so there appears a thick mix. Okay, thickness is there present. Okay, there is presence of the thickness, so that is a pseudo thickening. Okay, and when we do vigorous spatulation of that, okay, so it would cause the loosening of the mix, and the mix will be thinner. Okay, so first of all there is a pseudo thickening present. Okay, and after that, as I have written here, oil of orange. Okay, so oil of orange, it is the thing, okay, that we require to clean the eugenol cement from the instrument. Okay, so while spatulating with the stainless spatula, okay, so there is a there may be presence of the eugenol cement. Okay, after the proper manipulation. So for removing and cleaning those instruments, we use oil of orange. So this is a MCQ based question. Okay, so pseudo thickening appears thick during the early spatulation, and looking that thickness, okay, we call pseudo thickening. Okay, is present in the pseudo thickening is present in a zinc oxide eugenol. So just remember this. Okay, after that I have written in a two paste system. Okay, for two paste system, just what we do is, okay, so okay, equal length. Okay, we take just equal length of the paste. Okay, both the paste. Okay, so base and catalyst are present there. Okay, so we take the equal length of the both the paste. Okay, equal length should be present there, and we should mix that. Okay, and after when we attain the uniform color after mixing, okay, so after attaining of the uniform color, it is okay that okay we can use for our particular purpose. So uniform color should be absorbed, okay, after mixing. So mixing, when we mix, okay, so the uniform color, when it is attained, it is a final step, okay, so it is a final deadline that we have completed our manipulation, okay. So setting time is 4 to 10 minutes here, okay, and sets quickly in the mouth due to the moisture and the heat, okay. So the factor that affects the setting time, okay, I have written here, factor affecting the setting time, complete reaction takes about in a 12 hours. Manufacturing, in manufacturing steps, okay, so when we add the zinc hydroxide and zinc carbonate, okay, so when they are heated in 3000 degrees Celsius, they produce the active zinc oxide powder, okay. So from zinc oxide powder that are, okay, gained from those compound zinc hydroxide and zinc carbonate, okay, at 3000 degrees Celsius, okay, so those zinc oxide powder are the active, okay, and they can increase the setting. So they can decrease the setting time and increase the setting. After that, particle size, so smaller the particle size, there is a more setting and less setting time, similar with that of the this active zinc oxide powder. Accelerator means that accelerate the setting and decrease the setting time, and we have alcohol, glacial acetic acid, and the water, okay. So you can remember this by ways, okay, ways. Ways is the mnemonic, water, alcohol, and glacial acetic acid, okay. So WAG, ways is the mnemonic here, and in heat, okay. So if there is presence of the heat, so if there is a more temperature present there than fast setting, okay, so it will decrease the setting time. These four are similar. Similarly, the powder to liquid ratio is more, than it will be causing fast setting. And retarders, we have glycol and glycerin, so it is 2G, okay. Glycol and glycerin are the retarders of this, okay. After the manipulation section, now we will discuss with the modification of the zinc oxide eugenol. And in the modification of the zinc oxide eugenol, as I have told, it is a less strength cement, okay. So for strengthening the cement, we do modification in the zinc oxide, and the modification would cause the increase in strength of the zinc oxide eugenol. So the first modification is EBA alumina modified cement. So EBA means ethoxybenzoic acid alumina modified cement. So what is there, that it is a white powder plus pinkish liquid is there, okay. Similarly, the greater strength allows intermediate filling material and as the base, okay. So if there is strength, okay, so greater strength, so that as compared to the zinc oxide, okay, conventional zinc oxide eugenol, okay, it have the greater strength, and that allows it to be as a intermediate filling material and the base. So we can use as a intermediate filling, temporary filling material and the base, okay. So part of the liquid is the orthoethoxy benzoic acid, and alumina is added to the powder. So they both are added. Alumina is added in powder and EBA is added into the liquid. Now in the uses, okay, so as I have mentioned here, long-term cementation, okay. So some long-term cementation we can do by this cement, temporary and the intermediate restoration, and the root end filling, okay. So root end filling can be, in root end filling material we can use the EBA alumina modified cement. And in the composition, okay, so there is powder and there is a liquid. So in powder, as I have mentioned, there are major three constituent, okay. So zinc oxide, that is similar with the conventional zinc oxide eugenol, okay. And there addition is, and there is addition of the alumina, that is 0 to 35%, okay. So this is a range given here, okay, 0 to 35%, and hydrogenated rosin is present there. So as in the composition section, okay, so I will show you once, okay. So as in the composition section, as I have seen, as I have told earlier, zinc oxide is there, white rosin, zinc acetate was there, okay. So but here, okay, the resin part is quite omitted, okay, and there is a presence of the zinc oxide, and alumina is increased in this, okay, so that there is increased strength. Similarly, in the liquid there is ethoxybenzoic acid and eugenol, that is quite similar with that of the liquid of the conventional, but there was the eugenol, okay. So here is also eugenol, but there was 85%, here is 37.5%, and ethoxybenzoic acid, okay, is used in the replacement of the olive oil, okay. So olive oil was there 15%, here is 62.5%, okay. After that, the properties of EBA alumina modified cement are, so compressive strength is higher here, okay. So compressive strength is higher here, that is 55 to 60 MPa, as we add this alumina here. Tensile strength will be higher, okay, than conventional. Modulus of elasticity 2.5 GPa, film thickness is 25 micrometer, and solubility and disintegration in water is 0.05% by weight, okay. After that, it is mild to the pulp, okay. So mild reaction is present in the pulp, and it adhere to the tooth structure. So this is very important, okay. So as I have discussed earlier, there was no chemical bonding present, okay. So in addition section, okay, as I have told in a properties, I will show you. So as in the here, okay, Okay, so addition, no chemical bond was there in conventional, but here it adhere to the tooth structure. As we are using the orthoethoxybenzoic acid, so it would help in adhering to the tooth structure. Okay, after that in the setting time, okay, it is 9.5 minute. Okay, setting time it is 9.5 minute, and glass slab used for the manipulation after dispensing in a bulk is used. We incorporate needed. Okay, so we take a glass slab, okay, for the manipulation, and when we displace the powder and the liquid in bulk, we incorporate the powder into the liquid, similar with that of the conventional zinc oxide Eugenol, and we do kneading for the 30 seconds and stopped for an additional 60 seconds with the broad strokes of spatula. Okay, so first of all we do kneading. Okay, so and after that for 60 seconds we do broad strokes spatulation. Okay, so this is a manipulation process of this EBA alumina modified cement, which is not so important. So just you remember this. Okay, you can remember the datas. Okay, and this important adhere to the tooth structure. Okay, now in polymer reinforced ZOE cement, and this is our last paper for today's video. So in here, as I have written here, okay, so in polymer reinforced ZOE cement, okay, so resin added to the powder or the liquid. Okay, as there we add the alumina and orthoethoxybenzoic acid was added there, here we add is the resin, and it is the strongest of the zinc oxide Eugenol best cement. Okay, and it is used as a eluting agent, as a base, temporary filling material. Okay, quite similar with that of earlier, and it is available as the powder and liquid, and as in the form of the capsule. Okay, so conventional we don't get in a capsule form, we just get in a toothpaste form, but this polymer reinforced ZOE we can get in a capsule form too. And the composition, as we can see, there is a zinc oxide and finally divided in natural or the synthetic resin. Okay, so there is 18% U and 20% this. Okay, so earlier there was the zinc oxide, okay, alumina was there, but here there is a finally divided natural or the synthetic resin is here. And in Eugenol, acetic acid and thymol is here. So acetic acid and thymol, so acetic acid is acylator and thymol it is an antimicrobial. Okay, so the liquid acetic acid and thymol is in replacement of the, okay, olive oil in comparison to the conventional ZOE. After in the manipulation section, so proper powder to liquid is dispensed on the glass slab. Okay, and 50% of the powder is mixed into the liquid, and the remainder in the small portions with the vigorous spatulation. So first of all what we do is half of the powder we mixed in a, okay, so half of the powder we mixed in the liquid vigorously. Okay, sorry, we mixed it in a liquid softly. After that small portions we make of the left 50% of the powder, and there is a vigorous spatulation of that 50%. And here is we have long working time. Okay, so this is one of the advantage of this polymer reinforced ZOE. We have longer working time present here. Setting time is 6 to 10 minutes. Earlier it was 9.5 minutes. Okay, so in factor decrease in powder liquid ratio, increase in a setting time. Moisture if it is there, then it would decrease the setting time. Similarly, the cooling the glass slab slows the setting. Okay, so just remember those. So decrease in powder to liquid ratio means there is increase in the liquid. So if there is increase in a liquid, it would increase in the setting time. Okay, so it is simple. Okay, after that if there is a increase in a moisture, okay, so if there is moisture present, so there will be decrease in a moisture if it is there, and there will be decrease in a setting time, means there will be fast set. After the cooling, after that cooling the glass slab slows the setting. Okay, so it is also easy here. Now after that in properties section of this, okay, so compressive strength is 48 MPa, and there it was, okay, so I will just do compare here. So here it was 55 to 60 MPa. Okay, so how can you guess that? Okay, as the alumina is used here in ABA, okay, EBA, so that it must have a strong compressive strength. Okay, strong compressive strength should be here. Okay, so 55 to 60 MPa is the range here, but here it is 48 MPa, but there is not quite difference, a lot more difference between the both the ZOE. Similarly, the tensile strength is 4.1 MPa, it is also 4.1 MPa here. Similarly, 2.5 GPa is here, and here is also 2.5 GPa. Film thickness is 32 micrometer, here it is 25 micrometer. Solubility and disintegration is 0.03%, here it is 0.05%, and here it is moderate pulp response, here it is a mild to pulp response. Okay, so moderate is here and mild is here. Okay, and also improved abrasion and resistance and the toughness is present there. Okay, after that our third modification is the vanillate esters. Okay, so vanillate esters means here we use hexyl vanillate plus ethoxybenzoic acid. Okay, so EBA. Okay, so EBA alumina modified cement is present here. Okay, so in this cement EBA alumina modified cement we just add a hexyl vanillate. Okay, so it is a modification in the modification. Okay, So we do modify in the modified cement. So hexyl vanillate is added in a EVA, so it also increases the strength and decreases the solubility and the disintegration. Okay, so just remember this hexyl vanillate here. And after that, in our fourth modification section, there is a presence of the special product of the ZOE, that is a ZOE. Okay, so in this what we do is we add different kinds of thing. Okay, just like we add antibiotic, steroid, barium sulfate, okay, according to our use. Okay, so we use those, okay, antibiotic, steroid in the ZOE. So these are called special products of the ZOE, special combination of the ZOE. Okay, so we use it in a pulp capping, RCT, okay, root canal treatment. Similarly, the thing that we should remember is there is called a Richard's formula or Grossman's formula. Okay, so it is important here. So it is a traditional formulation for the endodontic sealing. Okay, so one thing I want to tell that this zinc oxide eugenol cement is widely used as a endodontic sealing. Okay, so there is a proper formulation, okay, traditional formulation for the endodontic sealing. Okay, so formulations are prepared for the endodontic sealing, so that is called Richard formula or Grossman's formula. Okay, so this is important to remember here. So as we completed all the topics of today's video, so this much for today. If you love this video, please do like, share, and share with your batchmates, subscribe, and also hit the bell icon, okay, so that you will be getting notifications of all those new videos, okay, that I am uploading on my channel. Okay, so on daily basis I am, for now on the daily basis I am just uploading the topics of this dental cement in my channel. Okay, so stay tuned for more the videos, okay, more dental related videos. I think in next video I will take the GIC, or let's see. Okay, so stay tuned, stay happy, stay healthy till then. Okay, also one thing I missed here. Okay, so if you need the notes of these videos, okay, so you can join my Telegram channel. Okay, so there I am keeping all the notes of the chapters, okay, all the notes of those videos, okay, that are so this note, from those note I am teaching here, so this note are kept in my Telegram channel, so you can join the Telegram channel for those notes, okay, and study properly after watching those videos. Okay, so you can also follow me on Instagram and the Facebook. Okay, so I have pages on both the platforms. So for now, tata, bye bye, thank you.